Our goal today is to apply solving systems to application problems. Bill and Steve decided to take an afternoon and go to the amusement park. You can see the tickets required to ride the water slide was $3, the Ferris wheel was $3, and the total to get in was $17.50 at Fun Time. And over here at Fun Time Amusements, you also see that the water slides are 2 tickets, the Ferris wheel, and the total was $15.55. Now, if you look at why these look so similar, it's because this was Bill's ticket and that was Steve's ticket. Now, their tickets are stamped each time they ride or slide, is what the little stamps or check marks are. At the end of the afternoon, they have the following tickets. So the question says, how much does it cost to ride the Ferris wheel? How much does it cost to ride the water slide? And you're going to draw that information off of Bill and Steve's tickets. So first thing, just like yesterday, you have to define your variable. So what are we going to make? Which ride is going to be X? And it doesn't matter to me. You all decide. Okay, X can be water slide. And by default, that makes the Ferris wheel Y. So when we start with our first question, which is how much does it cost to ride the Ferris wheel? And how much does it cost to ride the water slide? We are going to set up a system of equations. So he rode 3 trips on the water slide, 3 trips on the Ferris wheel, for a total of $17.70. And that was Bill. And then Steve is going to do 2 rides down the water slide, 3 rides on the Ferris wheel, and pay a little bit less. As he should, because didn't he ride 1 less time on the water slide, Steve, than Bill?
Can you just say 1770 minus 2?
Let's listen to Tate's conjecture and let's check it out mathematically. See if his conjecture is correct of how much X is, all right? Because if he's right, this one would have a shorter way to do it, right? Not all of them, but this particular one, because he could right on the get-go tell how much the water slide was. So let's see if he's right. Now, if you solve this by elimination, what would I do to this entire second row to get the Y to eliminate? Multiply by -1. So 3 minus 2 leaves you an X. 3 minus 3 disappears. 1770 minus 1555. Was Tate's conjecture correct? That couldn't you just subtract the 1555 from the 1750 to see how much it cost to ride the water slide? Was he right? So then back substitution, 3 times 215. And again, you can pick either equation. I just picked the first one. So it looks like to ride the Ferris wheel is $375. If they want to come back on Friday, could you quickly then calculate how much they would pay for riding certain rides once you know how much they cost? Yeah. Does there appear to be a flat fee to get in this park? Doesn't. It's just you come in, you buy the tickets, you ride the rides you want to ride, and then you pay on your way out. That's what it appears to be. All right. Tickets to a high school play cost $1.10 for each adult and 40 cents for each child. So obviously this question is like from 1928. If 360 tickets were sold for a total of $282, how would you find out how many tickets of each type were sold? So again, first, what is X? I don't care, y'all decide. Adult, that's fine. And how much are kid tickets? Or what? Oh, by default, we'll make it Y. So we have adult tickets and child tickets. Now it says that they sold 360 tickets. So however many adult and child tickets they sold have to sum to 360. We don't know the ratio and proportion of how they compare to one another yet, but they have to add to 360. Then it says an adult ticket is $1.10. So you're going to increase your income by $1.10 for each X ticket you sold. And then for each Y ticket you sold, your income will increase, bless you, by 40 cents. And what you took in the gate was $282.60. How would you guys attack this problem? Why substitution? Because the ugly decimals in the second one. Okay. So let's let y equal then negative x plus 360. So now everywhere that y was in this equation, it's going to be replaced with negative x plus 360. Bless you. What did you all get? So I got 198. Anybody get that? Okay. So what does that go with, kids or adults? Adults. Did somebody get something different, Keandre? Did you get something different? No or yes? Are you with me? Yeah. Okay. And then what are we going to do to get y? Yes, correct. I'm just going to plug it back in, negative 198 plus 360. And the child's tickets were sold were 162. Now, I do need to check it because what can easily happen is get these reversed. So I'm going to say 198 plus 162, does that equal 360? And sure enough, it checks out. Then I'm going to plug in 110 times 198 plus 40 cents times 162. I'm going to check and make sure that's 182.60. And 282.60 indeed equals 282.60, so I'm good on both counts. Look and see if there's any of these I want to go over before. I think all of these run exactly consistent to this. Tomorrow we will go on to 3 by 3, solving 3 equations, 3 unknowns, so we'll throw some matrices in there. Out of these 6 that you have for classwork, I want you to work at least 1 by matrices. So I'm going to go back quickly to this little guy right here, and we are going to add to our notes under Bill and Steve's tickets how to work this by matrices. Remember, first you have to set up the coefficient matrix, the variable matrix, and the constant matrix. Then to get y by itself, you cannot do the normal like you do in real numbers, division, because it's times. So you have to remember, oh, I'm going to find the inverse. You may find it by hand if you would like, or you may use your calculator. Remember to move from this side of the equal to the other side. It requires an inverse of that matrix. Then you would multiply it by the constant matrix, which was already on the left side. We're looking, of course, to receive the same answer as we did the first time. I need a 2 by 2, so 3, 3, 2, 3. X to the negative 1 is the symbol for inverse, times, then I will need a 2 by 1, so I'll insert that and fill that in with $17.70 for Bill and $15.55 for Steve. And I'll let the calculator tell me if we had it right. Did we have it right initially, 215 and 375? We did, didn't we? So at least one of the 6 that you're going to do in class today, I would like to be done by matrices, just so you can practice, because tomorrow we'll be doing 3 by 3s, and you'll want to know or remember how to do that.
Can we do all of them by matrices?
You may.